Reaction set 4 and 5 will deal with some decomposition reactions. So the first type of decomposition is a review from set 1, where a binary ionic compound breaks into two elements, possibly diatomic. So if solid calcium oxide is heated, it would form calcium and oxygen is diatomic, and then you would go back and balance the reaction. Molten potassium iodide is electrolyzed. That means it's zapped with electricity, and we'll do more on that in the electrochemistry section, but it will decompose the compound. And so potassium iodide would give you neutral potassium and then diatomic iodine. Remember, when elements are by themselves, they do not have charges, they are neutral. So there are no charges on any of these elements, and then you balance them. If solid magnesium chloride is decomposed, it would break down into magnesium and diatomic chlorine, which already balances. So a second type of decomposition is when a metal carbonate breaks down to give a metal oxide plus CO2 when it's decomposed. And so you'll have a metal, some positive ion that will form the metal oxide on the other side, and you always get carbon dioxide, CO2. So in the first example, magnesium plus 2 is our metal. And we want to make a metal oxide, so we're going to put it with the ion oxygen O minus 2. And so the formula MgO and plus carbon dioxide, CO2. And that one happens to already balance. In the next case, lithium is your metal ion. So we'll put lithium plus 1 with O minus 2. So our formula is Li2O. And then we'll form carbon dioxide gas. And that one also happens to balance. There are two exceptions to this pattern. One of them is carbonic acid, H2CO3. We've mentioned this example before. It's an unstable compound. It breaks apart very quickly into water and CO2. The top example has ammonium in it, the ion. It becomes ammonia on the other side, loses a hydrogen. And that would leave us with some hydrogen from the polyatomic and the carbonate from the original compound. And then it does something very similar to the bottom reaction. The hydrogen and the carbonate end up forming water and CO2. And you would need to balance the equation. Potassium carbonate is solid is heated, so potassium plus 1 is our metal, and we're going to form the compound with oxygen plus CO2, and that one balances on its own. In the next case, aluminum plus 3 is our metal ion. So you have aluminum plus 3 and oxygen minus 2, so the formula that forms would be Al2O3, and then we always get carbon dioxide gas. And you would need to go back and balance the carbons and oxygens by putting a 3. The third decomposition type is when you have a metal chlorate and you're going to form a metal chloride. Chloride is Cl minus 1 in a compound plus oxygen gas. Remember, oxygen is diatomic. So in this first case, magnesium is our metal, so magnesium plus 2, and we're going to form a chloride, so we're going to combine it with Cl minus 1, and the formula would be MgCl2 plus diatomic oxygen, and then we would need to balance the compound. The oxygens need to be balanced. In ammonium chlorate, our polyatomic is ammonium. It's not a metal, but that's our positive ion, and we're going to put it with chlorine minus 1 to make the metal chloride, or the positive ion chloride, and that would give you that compound, and then you would have the oxygen left over. And then you would need to go back and balance the oxygens, and then put in the coefficients. In this example, potassium is the metal, so potassium plus 1. And we're going to make the chloride, so you'd have potassium chloride plus oxygen, and then we'll balance the equation. In this case, barium is the metal ion, and we'll put it with chlorine to make the chloride. And then again, oxygen is diatomic, and then we'll need to balance those. So those are the first three types of decomposition reactions. There'll be one more type on set 5.